Today we're in section 13.4, graphing linear equations in slope-intercept form. Really the first couple sections of this chapter have kind of been building up to this point and laying the groundwork for you. One really important part of this, and I just kind of copied out of your textbook, you don't have to write down anything over here to the left. But we have the equation y equals mx plus b. Mx plus b. And this is what we call a slope-intercept form. You do need to write this down in your notes. This is very, very important. Okay? Where m stands for, does anybody remember what does m stand for? M stands for the slope. And b stands for the y-intercept. The y-intercept. What does it mean for something to intercept?
To take away.
Not to take away, but to cross. Okay? So the y-intercept, what this is saying is whatever number is right here at the end of the equation, that is the value that the line is going to cross the y-axis. That's a guaranteed point on the line. Okay, so that's going to be really helpful actually when it comes to graphing using slope-intercept form. I don't have to use a table. Remember when we graphed using a table? -2, 0, and 2, that was my standard numbers. You guys remember that? We don't have to do that now. We can just look at the equation and say this is my slope, this is my y-intercept, and that's all we need to know to graph it. All right, so it's actually a lot less work this way. Okay, slope and y-intercept. Is everybody good there? Do you understand what does m equal? What does m stand for? What does b stand for? Y-intercept. Okay, so now in example 1, we're going to identify the slope and y-intercept. Okay, that's really important because it builds it directly on example 2 and where we're actually going to use that to graph. So in example 1, the first thing I need to teach you guys is to be able to recognize if an equation is already in slope-intercept form or if you need to do something to the order. All right, so this is something we kind of struggled a little bit in the last quiz. If we need to do something in order to get it in slope-intercept form. All right, go ahead and write down these two equations. Okay, so in order to tell if it's in y-intercept form, I have to make sure is y by itself on one side of the equation. Yes. Guys, look up here. It's y by itself. Yes. And then the term that has the slope and the x. And then the number by itself. Okay? So this is in slope-intercept form because y is solved for. And then I have x. And then I have my b. Okay? So because it's already in slope-intercept form, I can just say m equals and b equals. M equals something, and then B equals another value. And whatever number is in the location where the M normally is in the formula, that is your slope. That is your slope. M equals 3, and B equals what? No, -6. Okay, if there's a sign in front of the number, I have to pay attention to it. So B equals -6. All right, I want you to pick out your slope and y-intercept, your M and your B value on the second one now. All right, who got the M? What is M? Someone raise your hand. Anybody? Gabe? -2/3. Very good. And what was B? Ayana, did you get B?
3.
B is 3. Very good. All right, so all we're doing is identifying. We're not solving anything. That's nice, right? You have a whole section like that on your homework, and it's on your quiz tomorrow. All right, just say M equals and B equals. Now, look at these two. Okay? Same example, but what do you notice that's different about these equations?
It's different.
Zach?
Y is not inside. Y is not outside.
Y is not solved for. This is not in slope-intercept form. So I have to do some steps to get it in slope-intercept form. I can't just say Oh yeah, my m value is 3 right here because 3 is connected to x. I can't do that yet because it has to be in slope-intercept form first. Okay, so what would I do to get y by itself here on this first one? What could I do? Kennedy?
Subtract 3x.
Yes, okay. So the question is, what can I do to get 3x to cancel to 0? Well, if I want 3x to cancel to 0, I would have to subtract 3x, right? 3x minus 3x is 0. So that's why I have to subtract 3x from both sides. All right, minus 3x. Don't forget your formula, okay? Minus 3x from both sides. Y equals, now according to slope-intercept form, which one of these terms has to come first? Negative 3x plus 6. And remember, guys, I cannot add them together because they are not like terms. One has an x and one doesn't. Now that I have it in slope-intercept, now I can say m equals and b equals, just write it down. All right, or say it out loud. Okay? All right, m equals what, class? Negative 3, and b equals 6. And ironically enough, that's all the information I need to know to graph it. I'm going to show you that in example 2. Yes. You don't need a table. You don't need the ordered pairs. That's all you need to know. All right. Now, I want you to get the second one in slope-intercept form. Negative 4x plus 2y equals 12. Okay, what do I do first? Noah, what did you do first to get this?
Plus 4x on negative 4x and plus 4x on 12.
Very good, because he knows that that's going to cancel out the 4x's. And now I have 2y equals 4x plus 12. Okay, Gabe, what did you do next?
Since we have to get y by itself, I subtracted 2 from every single number.
Okay, so you're correct to do it across the whole equation, but not subtract 2, but what? Divide by 2. Divide by 2 across the whole equation. Y equals 2x plus 6. So, class, what is m?
2.
M is 2, and what is b? 6. All right, so I know you're probably wondering, how in the world am I going to use this information, these two numbers, to actually graph the equation? Well, I'm glad you asked, because I'm about to show you. Okay, so in example 2, you have a new equation, y equals negative 3x plus 3. I want you to write that down. Okay, and then I want you to go off to the side. It doesn't have to be perfect, guys, but do not squish your numbers together. Each number should be a line, okay? Each dash should be one of the lines on your paper. Go ahead and use your rulers to neatly sketch a graph next to example 2. We're going to do 3 graphs total today. You can use graph paper if you'd like, or you can just use your notes. All right, the first question you want to ask yourself is this equation in slope-intercept form? Is it in slope-intercept, guys? Yes, it is. Y is by itself, then x, then b. All right, so now I want you to say, what is m equal and what is b equal? M equals and b equals. Go ahead and write that down. M equals and b equals. What is your slope and what is your y-intercept? M equals and b equals. What does m equal, guys? What does b equal?
3.
Now, at the beginning of the lesson, and I'll show you in a minute why I put negative 3 over 1. At the beginning of the lesson, we called b what? B is the, I heard it, the y-intercept. We talked about, what does intercept mean? It means to cross something. So, if the equation is telling me that my y-intercept is a value of what? 3. That means it's a guarantee that the line will cross the y-axis at a value of 3. I can plot a point there at a y value of 3. Okay? I can plot a point there. So when you just look at that equation, all right? Now I want you to go back and look at the original equation. This last number in the equation is your first point. If it's a -2, your point goes on a y value of -2. If this point, or if that number is a 6, then your first point goes on a y value of 6. Okay? But you need 2 points to draw a line. So your first point goes on the y-intercept, and then you follow your slope. Just as a refresher, your slope is rise over what? Run. Now you follow your slope from that point. So from the point that's up on the 3, you follow your slope where? Up 3 or down 3? Down 3 and over 1. You see, if I had a whole number and I didn't put any numbers in the denominator, I might forget that I'm supposed to run 1. I might forget that. Okay? So that's why I put it there. So I go down 3 over 1 from that first point, and then I draw my line through it. And I write the equation on the graph. Okay? And that's just kind of like a label. All right? We have to identify now the x-intercept. After we have graphed it, we need to now look at the line that is graphed. What value does the line cross the x-axis?
1.
A value of 1. So you would say x-intercept is 1. Okay? So you'd say x-intercept is 1. Okay? All right, so now we're going to do another one. We don't often do 2 examples of the same problem, but I feel like with this one we need a little more practice. What's up?
So on n, you always put a 1 under?
If it's a whole number. On the next one, you're going to see that it's already a fraction, and then you're good. But anytime it's a whole number, you want to put it over 1 to remind you to run 1. Otherwise, you might think you're just going straight down, and then you'll mess up your graph. Okay? Kyle? The x-intercept came from looking at the graph, and I see that the line intersects the x-axis at a 1. Okay? So that's just what they want to do at the end. They want you to kind of just acknowledge that, basically. Okay? So we're just trying to continue to get better. All right, here's our next graph. Y equals -1/2 x plus 1. I want you to tell me m equals b equals. All right, and then set up your graph. And some of you might be able to go ahead and get your points on the graph, if you remember what we did on the last one. Okay, so what is m, guys? What does m equal? M equals what? M equals -1/2, and b equals... What does b equal? 1. Very good. I don't know why this is messing up. Sorry. Okay, so m equals -1/2 and b equals 1. All right. Does anybody have the first point already on their graph? Do you remember what I do?
Oh.
What do I do? Where does the first point go on my graph? Kayla?
Wait, oh.
Yeah.
You know how to put b equal 1?
Yep.
1 is going to be the first point.
Yes, very good, very good. Because that number on the end of the equation tells me that that's where the line intersects the y-axis. Now, from that point, where do I go? Can anybody raise their hand and tell me? From that point, where do I go? Jason? Okay, to left or to right? Do you guys remember what we said about that negative? Yes, okay. You're right, though, to go down 1. That negative is the rise, but it is not the run. The run is never negative. I always go forward. Okay, so I go down 1, and I go right 2, and I plot my point and draw my line. Okay? And there's my 2 points that I need. All right, you got it? Now you need the x-intercept. Tell me the x-intercept.
1, 2.
X-intercept.
Yeah, 2.
Where does the line cross the x-axis? On a 2. X-intercept. Okay, so guys, on number 26 on your homework tonight, it will ask you to identify the x-intercept, so don't forget that. Okay? All right, any questions? Okay, we've got one more slide. I'm with you, bud. I got a headache too. It's rough. I literally woke up with. Has anybody ever done that? You woke up with a headache? It's brutal. Okay. Okay, guys. Example 3. Here we go. Okay, so in this example, it says the cost Y in dollars. Remember when we were giving X and Y kind of these labels yesterday? Okay, well, the cost Y in dollars of a taxi, taking a taxi X miles is represented by the equation Y equals 2.5X plus 2. Obviously, that's going to be pretty important. So they want us to graph the equation and then interpret the y-intercept and the slope. Okay, so from this equation, I want you to tell me what is M equal and what is B equal and set up your graph. And then we'll do the interpretation. Okay, M equals B equals, set up the graph and the interpretation. Okay, what does M equal? 2.5. And what does B equal?
2.
Okay, 2. Now, here's the problem. If I want to graph this, I need rise over run for my slope. I don't need a decimal. So how can I write 2.5 as a fraction? Okay, 2.5. And then could I change that to a mixed number or to an improper fraction?
Yes.
What would it be? 5 over 2. Okay, so I've got to have it rise over run. All right, now you think you can get that on a graph? Go ahead and try to do that completely on your own. Okay, so where is my y-intercept, guys? Where does my first point go? 2. And then where do I go from there? Nope.
Up 5.
Yes, up 5 over 2. I don't know why I have that random point there. Up 5 over 2, and I draw my line. Okay, but what does this all... who got the graph right? Anybody get the graph right? Who got the graph right? Okay. What does this mean? What does the slope mean? What does the y-intercept mean?
Does it have an X?
Okay, so let's talk about the y-intercept first. Okay, in terms of what the values mean. What did my y value stand for? What did it stand for over there?
2.
Dollars. Dollars. Y is dollars, right? Okay, and X stood for what? Miles. Okay, so let's talk about this ordered pair here that stands for the y-intercept. Does everybody agree this ordered pair is 0, 2? That stands for the y-intercept, right? I go over 0 and up 2. So at 0, what was my label for X? At 0 miles, how much did I pay? $2 for the taxi. All right? So what does that mean? Literally, as soon as I get in the taxi, before I go anywhere, I'm paying $2 just to get in the taxi. Okay? So I could ask them to take me 15 feet, and they'll be like, that'll be $2. Okay? It's just a flat fare. It's a flat fee. A lot of times that'll happen. All right? So that's my interpretation. I'm going to pay $2 at a base cost for the taxi. 0 miles. Okay? If you say it costs $2 to ride 0 miles, that would be correct too. But you're acknowledging I'm not going anywhere on X. I have no X value, and it still costs me $2. Now, while you're kind of processing that, is this a proportional relationship? Does anybody remember the criteria for a graph? Yes. Does this pass through the origin? No. So in order for this to be proportional, it would have had to be 0. When I go 0 miles, I pay $0, right? So it doesn't mean it's not a linear equation, just means it's not proportional. So what about the slope? What does the slope mean in terms of cost as it relates to miles? What is the slope telling me in terms of cost as it relates to miles? You can look at the graph to kind of, okay, where's my next point? How many miles? At 2 miles, how much did I pay? No. Up here. There it is. Okay, so I went 2 miles and I paid $7, right? So what does that tell me about going 1 mile?
$3.50.
$3.50 per mile. Now, I would say that I would accept either answer. If you said, I pay $7 to travel 2 miles, or I'm sorry, $5. My bad, $5, because from 2 to 7 is 5 more. You could say I pay $5 to travel 2 miles, and guys, that's what the slope is telling me here. Okay, I pay $5. That's my rise to travel 2 miles. That's my run. All right, or you can go back to, what did we say? It's either $5 for 2 miles, or it's $2.50 for 1 mile. Sorry guys, I forgot we're supposed to start at the actual point, not back at 0. All right, so, and look here, that's what it says here, $2.50 per mile. All right, so either interpretation would be correct, $2.50 per mile, or you could say $5 for every 2 miles, which is what the slope is also telling me. All right, that's everything you need to know for 13.4.